Hello, my name is Reika Meyrisah. Today I will be presenting about the zero waste supply chain. Next is a table of contents containing the contents of today's presentation points. Let's get straight to the background of zero waste supply chain management.
Rising global awareness of climate change, plastic pollution, and resource scarcity, many companies are beginning to adopt zero waste approaches in their supply chain management. This concept aims to minimize waste throughout the entire product life cycle, from raw material sourcing to end-of-life product handling, guided by the principles of reduce, reuse, recycle, and redesign.
However, the practical implementation of a zero-waste supply chain still faces many challenges. In industries like food, textiles, and electronics, waste generation remains high due to non-sustainable materials, inefficient logistics, and inadequate recycling infrastructure. On the positive side, multinational companies such as Unilever, IKEA, and Nestlé are integrating circular economy policies and take-back programs into their supply chains. Technology plays a key role, with blockchain enabling waste traceability, AI optimizing production, and IoT supporting smart inventory management. In Indonesia, the concept is gaining attention alongside government efforts to promote a circular economy and reduce plastic waste. However, comprehensive implementation still requires education, stakeholder collaboration, and stronger regulatory incentives. Implementation of a zero-waste supply chain encounters several interrelated and complex barriers. One of the most significant is the high initial cost required to begin transitioning toward zero-waste practices. Companies often need to make substantial investments in new technology, employee training, redesigning production processes, and modifying logistics systems. This is particularly burdensome for small and medium enterprises with limited financial resources. Another major obstacle is the limited availability and capability of recycling technology. Not all waste materials can be efficiently recycled or repurposed due to the lack of advanced and integrated waste processing infrastructure, especially in developing countries. This hampers the achievement of circularity within supply chains. The lack of supplier support further complicates efforts. Many suppliers are not yet practicing sustainability or are reluctant to change due to cost concerns or operational disruptions. This lack of alignment within the supply chain makes it difficult for companies to achieve a truly zero-waste system. Several industries are making notable progress toward achieving a zero-waste supply chain, even if full realization remains challenging. Among the most prominent examples are 1. Outdoor apparel industry, e.g., Patagonia. Patagonia has become a global model for sustainability. Industry, e.g., Toyota. Toyota has implemented lean manufacturing principles through the Toyota Production System, TPS, which focuses on minimizing waste, defects, and overproduction. 3. Technology industry, e.g., Apple. Apple is actively working toward a closed-loop supply chain, aiming to eliminate the need for new mining by reusing materials from old devices. 4. Food and beverage industry, e.g., Nestlé. Danone. Some companies in the F&B sector are piloting zero-waste production facilities. Technology plays a critical role in enabling and accelerating zero-waste supply chains by improving visibility, efficiency, and decision-making across all supply chain stages. Here's how. 1. Data tracking and waste monitoring, IoT, Internet of Things. IoT devices can track material usage, waste generation, and energy consumption in real time. This allows companies to identify inefficiencies and reduce waste instantly. 2. Artificial intelligence, AI, and predictive analytics. AI analyzes patterns in production, inventory, and logistics to predict demand more accurately, preventing overproduction and overstock, two major sources of waste. 3. Blockchain for supply chain transparency. Blockchain ensures traceability of materials and waste through every point in the supply chain. This helps verify sustainable sourcing, measure environmental impact, and prevent greenwashing. 4. Advanced recycling and sorting technologies. Innovative recycling systems use robotics, machine learning, and chemical processes to separate and recover valuable materials more efficiently, reducing landfill waste. 5. Digital twin and simulation tools. Digital twins simulate the supply chain to test different waste reduction strategies before implementation, helping companies plan low-waste models more effectively. 6. 3D printing and on-demand manufacturing. 3D printing reduces waste by producing items only when needed and using precise amounts of material, minimizing leftovers and defects. 7. Product Lifecycle Management (PLM) systems. PLM software supports sustainable product design by managing data from concept to end of life, ensuring products are built for reuse, recycling, or remanufacturing. Consumers play a significant and often underestimated role in the success of zero-waste supply chains. Their influence can be seen in the following areas. 1. Demand for sustainable products. When consumers actively seek eco-friendly, recyclable, or minimal packaging products, companies are pressured to adopt sustainable practices across their supply chains to meet that demand. 2. Purchase and disposal behavior. How consumers use and dispose of products affects the overall waste output. Responsible behaviors such as reusing, recycling, and participating in take-back programs support circularity in the supply chain. 3. Market pressure on brands. Social media and public opinion can quickly hold companies accountable. When consumers prioritize sustainability, brands respond by redesigning products and packaging to align with zero-waste goals. 4. Support for business models like refill and reuse. Zero-waste initiatives like refill stations, reusable packaging, and subscription-based circular services, e.g. Loop, rely heavily on consumer participation. 5. Feedback and advocacy. Consumer feedback pushes innovation. Brands often adjust strategies based on user experience and expectations regarding environmental impact. No, zero waste does not mean the complete elimination of all waste in an absolute sense. Instead, it's an ideal goal and a guiding principle that focuses on minimizing waste as much as possible and ensuring that materials are reused, recycled, or composted rather than sent to landfills or incinerators. The Zero Waste International Alliance defines zero waste as a goal to redesign resource life cycles so that all products are reused and very little or nothing is discarded. In practice, achieving absolute zero waste is extremely difficult, especially in industries dealing with complex materials or hazardous waste. So, zero waste is less about perfection and more about continuous improvement, designing products, systems, and behaviors that move us closer to a circular, sustainable economy with minimal environmental impact. Several realistic supply chain management (SCM) strategies can effectively support the transition to a zero-waste model. These strategies focus on reducing waste generation, promoting reuse, and enhancing circularity across the supply chain. 1. Lean manufacturing. This approach aims to eliminate all forms of waste, materials, time, energy, by improving efficiency, streamlining operations and minimizing overproduction and defects. 2. Circular economy integration, designing supply chains to reuse materials through repair, remanufacturing, and recycling helps close the loop, minimizing virgin material use and preventing landfill waste. 3. Reverse logistics. This involves creating logistics systems that enable product returns, reuse, refurbishing, or recycling. It supports take-back programs and product life extension. 4. Supplier collaboration, working closely with suppliers to adopt sustainable materials, reduce packaging, and follow ethical sourcing practices ensures that waste reduction starts upstream. 5. Demand forecasting and inventory optimization using technology, e.g., AI. Predictive analytics, to improve demand forecasting, helps avoid overproduction and waste from unsold or expired inventory. 6. Green procurement, sourcing products and raw materials that meet environmental standards reduces downstream waste and supports cleaner production processes. 7. Product lifecycle management, PLM. Managing products from design to end of life ensures materials are tracked and planned for recycling or reuse from the start. A completely zero waste supply chain, where no waste is generated at all, is theoretically possible but practically very difficult to achieve in today's global economy. Complex product designs, mixed materials, inconsistent recycling infrastructure, and varying consumer behavior make true zero an ambitious ideal. However, the goal of zero waste is not perfection, it's direction. It's about designing systems, products, and supply chains that minimize waste, maximize reuse and recycling, and create a circular flow of materials. In that sense, a zero-waste supply chain is not impossible, but it requires a strong commitment to sustainability at every level, from design to delivery. The use of innovative technologies and data-driven decision-making, collaboration between companies, suppliers, governments, and consumers, a mindset of continuous improvement, not instant perfection. So while the label zero may sound absolute, its true meaning lies in pursuing the lowest waste impact possible, and that is both realistic and necessary in today's climate-aware, resource-limited world.